Software Engineering Radio, episode 125, Performance Engineering with Chris Grindstaff.
This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio brings you relevant and detailed discussions and interviews on software engineering topics every 10 days. Thanks to our audience and the partners listed on our website for support.
So, welcome listeners to our new episode on Software Engineering Radio. This time we talk about performance engineering, and therefore we invited a guest, Chris Grindstaff, and I'm pretty happy that he took the time to discuss the performance engineering with us. So, Chris, would you like to introduce yourself?
Sure, thanks. So I work at IBM, where I'm a performance analyst and a performance engineer. And the last several years, I've focused primarily on IBM's client applications. So specifically, Same Time and Lotus Notes are some applications that I've worked on. And I started at IBM out of college and stuck around for about 18 months before leaving for a small company of about 10, where I blissfully spent 8 years doing some great stuff with some great people, and then have actually been back at IBM for I think about the past 5 years.
And you're there mostly involved as performance engineering team lead, or what is the focus at IBM there?
Yeah, it's the performance analyst for Lotus Notes at the moment. So it's definitely a team lead. I'm working with both development customers and the test organizations to try to drive performance improvements to IBM products.
Ah, cool. Okay, so I think we will not go into details of IBM products really, but what about telling our listeners what makes the application perform well? So what does performance engineering really means, and what does it mean for the application?
Yeah, that's an interesting question because of course one man's well-performing application is not another man's well-performing application. And so I guess I would answer that question by saying that it's really important to establish that up front. So whenever I'm working with teams, we work to establish concrete performance goals that are actionable and that we can track towards. And then the discussion becomes where should those goals be set? And often those goals will be set from a competitive analysis or simply from experience, rules of thumb, that anything UI related should take less than 200 milliseconds, or long-running operation should give user feedback. That sort of thing. A lot of heuristics coupled with sometimes guessing on what the performance goals should be.
So the performance goals are more or less defined informally, or do you have some kind of formal write-ups for them?
So as you might imagine, at IBM, they're pretty formally defined. And part of the reason I say that's because when I worked at the small company, there I did a lot of performance work. All the developers did a lot of performance work, but the kind of work we did there was more informal. So at IBM, we write into basically we write in ship goals that the product cannot ship unless it meets a certain level of performance. So they're very crisply defined goals that are many meetings happen to discuss what the exact numbers should be.
And those are defined in terms of, let's say, response time at the UI or throughput at the back end, or
Yeah, that's right. Typically, we'll for server applications, we often will define a something around transactions. So total transactions per second with an acceptable response time is sort of our catch-all for back-end goals. Client-side goals, we focus, because client-side is often a single user, we typically are looking at response time and things like memory footprint.
okay, you would say performance engineering does not only mean response times and throughputs, but also memory footprint?
Yes. Yeah,
Okay.
that's something that on the server side and the client side, customers are really sensitive to,
Mm.
and can be a challenge depending on what language and framework you are using.
It seems like you have concrete examples in your mind.
Well, you know, I think basic engineering says that more abstractions, more levels of indirection, more layers of framework don't come for free. And some applications find themselves sitting very high on application stacks. And there are great benefits and great challenges that come with that. And that's actually one of the really interesting things about working as a performance engineer is you really have to understand how all of those layers interact. You have to really understand the full system all the way down to the OS often to really realize the sort of gains and understanding that you need to. And in my experience, application developers, because they're so high on the stack, they often get siloed into focusing on simply the layer above them and the layer below them, and they can't really focus on the full stack.
If you have the full stack in your mind, do you think about more at the back end, let's say J2EE stacks or huge application servers or whatever, or the client side as well?
Yeah, the client side as well. I mean, a lot of the applications that I've worked on the client side are built atop Eclipse. So, at a simple level, you have the JVM, then you have Eclipse and OSGI on top of that, and often there will be other proprietary code on top of that, and then your application code. So even in a situation on the client, it's not hard before you're sitting on a pretty tall stack.
Oh, okay. I think we should come back to these OSGI and Eclipse platform on the client side later on. Sounds pretty interesting.
Sure.
Before we move forward, who defines the performance goals? So we talked a lot about which performance goals to define and how to define them, but who defines them in your case? Sounds like huge long meetings, or who defines it in the end?
Yeah, it's an interesting negotiation between the performance team, the development team, and the sales and marketing team. And there are a lot of interests, ultimately everyone is trying to create the product that our customers are going to like and that they're going to want to buy. So typically meetings involved with those three parties, you try to negotiate what you think you can do to meet customer goals or exceed customer goals and expectations, and at the same time not have a spiraling out of control development budget. And it's really a trade-off, like all engineering decisions.
Do you have any kind of ratio? How much time do you spend during the development of the project for performance engineering?
No, it for every release of a product that I've worked on, it's varied a lot. And I should also say that I sort of have the privilege working here in that I really work as a consultant to development. So that means I'm profiling code, I'm making code changes, and I'm reviewing code changes at the same time that the majority of the developers are adding features, fixing bugs, unit testing, the normal sort of development tasks. So in other words, IBM is large enough that really you can have two teams focusing like that. And when I worked for the small company, that obviously wasn't the case. You would each individual would split their time between doing some development, some performance.
Do you have some kind of feeling what is a good, let's say a good budget or a good percentage of the work of the whole team, let's say, developing a project, how much time to spend for performance engineering or how much time is necessary?
I don't. The way I would approach that question is going back to upfront stating the goals, right? Because and it's important to say that performance in and of itself has no value except to reach the goals that you've established, right? Because you can spend forever improving any given code path or improving your memory footprint, but there's definitely a diminishing return, and one of the ways that you handle that is by establishing goals up front, and once those goals are reached, then you don't work on those areas anymore. So a lot of it, I would say, comes down to how aggressive you make the goals.
Okay, and that might depend on the kind of product you're developing, right?
Exactly.
So if you develop a database, you might invest much more time optimizing the performance than if you develop a business banking application, a UI stuff.
Yeah, and another really common example is version 1 of your product has shipped. Customers like it, but they're complaining about performance. So version 2, performance is now a bigger issue, and it gets a lot more attention.
Yeah, good point. I think we will come back to the point when to optimize performance, and I think that the next logical question would be, how do you find performance bottlenecks and problems? So maybe which tools are you using, or are you using tools, or are you doing something else?
Yeah, so we've talked some about goals. The next most important, well, the next very important part after goals are having measurements. I like to say that you can't improve what you can't measure.
Mm-hmm.
And so I bring that up because it plays into the tools. You have to have solid measurements and ideally repeatable measurements with historical data to really move the ball forward in terms of improving the performance. So we split it up into measurements and then analysis. So the measurements tell you where you are relative to your goals, and then the analysis is responsible for telling you how to improve that, how to get closer to your goals or exceed your goals.
How do you do the measurement?
So measurement is very important and very messy. it it's not terribly sexy. It's a lot of work, and especially as our product is in development, it's very challenging to keep your measurement scripts in parity with with how the product is changing. So some of the tools that we use to do measurements are LoadRunner, which you may have heard of. That's really to test web-based applications.
Mm-hmm.
So it's JMeter is an Apache project that's similar. And what tools like LoadRunner or JMeter do are more or less screen scrape your application and then let you parameterize that screen scraping so that you can substitute virtual users for real users.
Mm.
And you use those tools to basically apply load to the application under test. And then just as important as applying the load, you then have to have performance metrics gathered as that load is applied. Because again, what you're really trying to do is you're trying to figure out at what point the load on the server becomes so great that the response time exceeds the goals that you established. I mean, this is especially important for web applications. The goal isn't really to knock the server over. The goal is to understand how end user response time varies as you apply more load.
Sounds like you've completely automated this kind of creating load and gathering those metrics.
Ideally, automation with constant validation, it's really challenging. Like I said, as a product is being developed, the UI changes, of course, and you have to be very careful that your automation scripts are doing the same thing that a real user would be doing. Not to mention that it's difficult to keep that automation in sync. So not only do you have to worry that it's doing the right thing, from build to build, it typically will break, and you have to go back and figure out what changed and fix it. It's a lot of work, which is frankly why a lot of people prefer to skip that step. There's a point at which you get diminishing returns. So one of the things that we try to do when we're establishing goals and when we're coming up with these measurements and these scripts is making sure that we hit the parts of the application that we think most of our customers will hit with the most frequency. Because the complexity of a lot of applications today make it very difficult to automate the entire thing. That said, that's what I'm describing right now is really, it's almost an external view of your application. I also, the other side of that are having developers through unit tests or through performance unit tests look at application performance from that point of view also.
Ah, okay.
So you can come at it from different angles. But a real important point to make there that we see time and again is, especially for web applications and really for client applications too, an element that is often missed in doing performant unit tests or having developers do their own performance testing is the huge impact that a well-populated database or a well-populated set of data has on those performance tests. In other words, it's not uncommon to have developers come to you and say, my set of functionality performs great. And you start asking more questions and you realize that, it was run against a database with 10 users, whereas our customers run it with thousands of users and they see very different behavior. So one of the big challenges, in addition to measurements, are having valid populations of data. And that's really, again, it's not sexy work, but it's really crucial to having a well-populated data to get remotely reasonable results from your performance measurements. and you can't really improve performance if you aren't measuring what your customers are really going to see.
Oh, okay, so it's somehow on the same level that you say your test setting should be as closely related to the real user setting as possible, right? So having the same,
That's right.
let's say you emulate the same amount of users, having the same size of data in the database, the same kind of load that thousands of users would create in reality for your performance testing.
That's right. Yeah, and as you can imagine, that sounds like a lot of work.
Mm.
And for for complicated web apps, it's a great deal of work. But yeah, I mean, a funny example of this are simple things like, and I see this on the client as well, like pagination, right? If the web app is serving back a screen that doesn't have any pagination, and that works well when you have less than 30, less than 50 elements coming back. But as soon as you start returning hundreds or thousands, then the end user experience, both the server load and the browser user experience suffer significantly. In the same way that if you think of something like a mail client, and if you have 2,000 or 3,000 messages in your inbox, you shouldn't have to pay the cost to touch all 2 or 3,000 messages to simply view the first page of your inbox.
Mm.
And those sorts of pagination issues come up time and time again because typically because developers are testing with a small set of data. So data population is really big.
You said that to find the performance bottlenecks and to see where you are, therefore the measurements are important. So do you think that you think that you first need to have some solid measurements and then you optimize performance, not the other way around? So having this kind of first make it run and then make it fast?
Yeah, um, I think it's gonna. I think it'll depend a lot on the size of the organization, the size of the team. I mean, obviously, if someone, comes to you and says, it takes me 4 minutes to log in, I would say it's actually very similar to how I've tried to introduce unit testing into organizations that aren't doing unit testing. It, it's rarely beneficial to boil the ocean and say you need to add unit tests for all your major functions.
Mm.
Instead, I would say, well, the next defect that you get in that comes in, try to write a unit test for that, fix it, and then accumulate a set of unit tests as you go forward. And I would say the same applies for performance testing. So in the example where it takes a long time to log in, ideally you would write a measurement for that or a performance unit test for that. Then you would fix the problem, and now you're accumulating a suite of measurements or performing unit tests so that doesn't regress in future builds.
Ah, okay. So doing the performance measurements and optimizations step by step.
Yeah, and it really will vary on the organization as to how you can do that. As I said, I'm sort of privileged to be able to approach performance in the way that I do here. I'm glad that I worked at a small company where that they simply couldn't do some of the things that we can afford to do here in terms of performance.
So you already gave one example of a typical performance problem, having this huge data and this paging or pagination.
hmm
Um, Can you give us a brief introduction or an overview of what are the typical performance problems that you observe in applications on the server side as well as on the client side?
Let's see. I'll start with the client side because that's where I've been spending more of my time recently. Startup is an interesting one because at some level you would say startup isn't that important because a lot of people don't start up more than once a week or sometimes even a month because they suspend their machines or they simply don't start up that frequently.
Mm.
But the reality is, a lot of customers have come back and said that startup is very important to them, for whatever reason. And so startup is an area that I've been focusing on a lot, this year really. And that's a challenge. Any Java-based or Eclipse-based application has challenges in startup. So that's a typical one. Memory footprint is another typical one. Java applications in particular, and this is true on the client and the server, have lots of repetitive strings in memory. With the amount of XML parsing and XML that goes on in a lot of Java application servers, you have lots of memory dedicated to strings.
Mm.
On the client side, another big area are resource leaks, and I'm specifically here again talking about Eclipse-based applications where SWT SWT requires you to manage your own UI resources, basically.
Mm-hmm.
You can't rely on the Java garbage collector there, like you can in Swing. And then just the obvious ones of doing too much work in the UI thread, doing too much I/O is another area that we see, especially with cold startup.
Do you observe often algorithmic performance problems?
There are certainly algorithmic problems that come up. They're usually, in my experience anyway, they're usually great fun to find because a lot of which I should have actually started by saying that the first thing you have to do is determine whether or not you're CPU constrained or I/O constrained, and typically if your algorithm is the problem, you'll see that as a CPU problem.
Mm-hmm.
And often those problems, the reason I said they're fun to find is because they're often easier to fix than some other problems that I run into, because the profilers will typically, most profilers excel at finding CPU bottlenecks, and typically once you find those, they're, in my experience, not too bad to fix. Some of those that come to mind are, I'll occasionally see people using a list when they should be using a map. They're basically scanning the list looking for an item instead of using a constant time map. Is a simple example.
Yeah, but it also it's also related to the thing you mentioned earlier about the size of your data, right? Because if you have just
Yeah, absolutely.
10 items in your database, it doesn't matter if you scan a list or if you use a map. But if you have millions of items in your list, and if you real sized data volume, then you can observe those problems, right?
Yes, that's right. A simple order analysis shows that for a lot of VMs, under 100 items, you can get away with a list, and in some cases it's even faster. So you're right. I mean, that definitely feeds back into the population issue. So one of the ways that we try to approach that is take our systems that are fully populated and do the profiling of a single user on that system.
Mm-hmm.
That's one approach. And another approach is When you're looking at concurrency problems, typically a single user isn't going to show you much. It's not impossible to deadlock with a single user, but it's you usually find that pretty fast. So there's a bigger challenge when you're trying to profile an application that's under load, because most profilers skew and create enough overhead that you can't do that under load. So you have to fall back to often simpler tools. So yeah, population plays directly into the profiling and analysis.
So this is more or less the algorithmic side and some kind of low-level stuff. You talked before about the layers in applications and these huge technology stacks that we use today. So, what do you think? How important is the I name it now, architecture of the application for your performance goals and for the performance problems?
It's hugely important. And I should mention that is something else that we do here is the performance analysts attend all of the architect and design meetings to to bring the performance voice to the table, because as is often said, the earlier you fix the problem, or in this case even the earlier that you don't write code that isn't going to perform or scale, the better. But then to your point, there's a lot of challenge in building applications that sit on so many layers. The best that I can probably say there is that you really need to understand how the layers below you interact. OSGI and Eclipse-based applications are a good example. You really have to understand how bundles are activated and really try to embrace Eclipse's model of delaying activation as long as possible. It's unfortunately too easy to violate that. That possibly better tooling or better education might help with that, but it's a real challenge when you're sitting so high up on the stack.
Did you observe performance problems that were very, very difficult to solve because you need to change the architecture fundamentally, maybe, or change maybe important parts of the architecture to solve those performance problems?
Yes, definitely. I'm trying to think of a good example. I mean, OSGI, it was around, I think it was the move from Eclipse 2 to Eclipse 3. OSGI, well, at the time, Eclipse stored, as I was saying, a lot of XML in memory, and it was very redundant. And one of the changes that was made was basically to cache more of that and use indexes, use integers under the covers to represent the same information that you were pulling from your plugin XML. That's an example of an architectural change that was made in Eclipse to address some of the sorts of things I'm talking about. I wasn't specifically involved in that one.
But it sounds like this performance optimization was done inside a single layer of the architecture, let's say the whatever extension registry of Eclipse, and does not affect the whole application.
That's right.
So did you also observe those performance problems where you need to change, let's say, vertically your application from the base layers to the top layers?
Yeah, that definitely happened. Startup is actually a good example. Startup is one of those problems where when you profile startup, typically no one thing stands out, right? There's no obvious hotspot.
Okay.
Startup tends to be spread across the entire infrastructure. So I like to call it the death of 1,000 cuts, because you take lots of very small things and add them up, and then you get startup problems. So for something like that, there were no silver bullets. Obviously, it was minimizing or reducing the number of bundles that are activated. So in the last version of the product that I worked on, we basically cut that in half. And when you look at any individual bundle and you try to go to development and say you need to take this out of the startup path, you'll often get pushback, because what that one bundle contributes to startup is minimal. It's only when you take them in the whole that you can really see the full impact, which is sort of contrary to most performance advice of the 80-20 rule, or focus on the hot spots and fix those. Startup doesn't really play as well with that advice.
But if I think about my activities in performance optimizing or doing performance engineering stuff in my projects, I think I've observed nearly the same. So that sometimes there are problems where you can use a profiler and you find one hotspot and say, okay, this operation takes long because they're scanning a list instead of using a map or whatever, and it's easy to solve. Some kind of low-hanging fruit.
Mm-hmm.
And sometimes it's just some of thousands of small operations which you cannot really avoid, and all those operations are fast, and only adding them up, doing all of them at once causes a performance problem. So you would say that having this kind of performance problems, they're harder to solve, and one idea is to, let's say, move a lot of those operations to a later point in time. So having them done lazily after other operations, so you get better feedback or faster feedback.
Yeah, well, exactly. And I mean, another good example in Eclipse is Eclipse did a nice job of separating the code that needs to be run from text that needs to be displayed to users. And by that I mean Eclipse can show me the shell of a view, and that view can have an icon, and that view can have a title. And from an end user's perspective, I think that view exists, that it's real, that I can do something with it. But the reality is the code behind that view likely hasn't been loaded unless I've used it already. And so that's a nice way to defer all the loading of that code that's behind that view. And it was architected that way. That's the sort of thing that it's hard to change after the fact, right? Because most people would just write their Java class, and they would have the Java class return an icon, and it would return the label or the text to show the user. But as soon as you've done that, you now have to load that class, in any classes that it depends on. So it would be it's difficult to go from that to the separation that Eclipse made from the beginning. Those are architectural changes that are very hard to force in.
Do you think similar problems are also possible on the backend side? So having, let's say, a transaction doing thousands of tiny steps and causing a performance problem because so many small, fast operations they need to be done? And if so, do you have any ideas or any typical patterns how to solve those kind of problems? Because in those cases, for me, it sounds like it's not always possible to say, okay, I defer some of those operations to a later point in time.
Right. Yeah, I mean, for the back end, again, it's going to depend a lot on where your bottleneck is. For a lot of the applications that I've worked on the back end, the bottleneck ends up being the database. In cases like that, you really have to go to the database and ask it why these particular transactions or these queries are taking so long, right? And databases are generally very good at telling you why it's taking a long time. They don't always help in telling you how you can make it not, but they at least can show you the access plan and show you why it's taking a long time to return a query. And then with that information, you have to, often decide to restructure, add indexes, change the query, pull it, denormalize. I mean, there are a lot of ways that you can attack a problem like that. But again, it has to go back to first knowing that that's where you should look. And the way you do that is by monitoring the application server, the database server, LDAP, whatever servers you have while they're under load. And the measurements will tell you where those bottlenecks are, and then you have to just go to each one.
But having you mentioned the denormalization or restructuring of data or schemas or whatever, that brings me to the next question. Do you observe typical, let's say, situations where you need to do a trade-off between nice modular and clean design of your application or data structure, whatever, and performance goals? So where you say, okay, this will be a nice design, or a nice architecture, but we have to break it somehow and make it uglier to meet the performance goals?
Yes. Database denormalization is probably one of the examples that comes to mind there. I guess I would say though that the flip side of that is well-written code, well-factored code is also easier to make performance improvements to. I guess simpler is better, right? Less code is easier to improve than more code. So they don't always oppose each other, but they often do. Adding, another simple example is just concurrency. Having to add concurrency to your application unless you have the benefit of using some message-oriented concurrency. If you're in Java using monitors and Java constructs for concurrency, it often takes a simple application and makes it much more complicated.
Would you say that a good architecture and a good design makes the system perform well? Or would you say a good and flexible architecture makes it easier to improve the performance?
That's a good question. I can think of examples where that was true, and then I can think of lots of examples where it wasn't. Yeah, I mean, I keep going back. You can tell that I've suffered in the past, but I keep going back to being layer number 11 on a 10 deep layered architecture. Your opportunities to improve performance when you're that far above the stack are challenging. On the other hand, I've actually seen products that were in a situation like that where they were much higher up on the stack. In version 1 of their product, they got beat up in the market for it, and in version 2 of the product, they basically got rid of several layers beneath them, and maybe wrote directly to the servlet API instead of some of the layers that were between them before. And that's a lot of work, and a lot of products can't afford to do that, but sometimes that's the right thing to do.
But it sounds like you would vote for simpler architectures and fewer layers instead of making it all extremely complex and huge.
Absolutely.
Okay. Yeah, that's my impression as well. So having less technology and less layers and less abstractions is sometimes better than doing this kind of over abstracting everything.
Yeah, I think it's interesting having been in the Java space for a while and seeing what's going on the server side and the complexity there, and how frameworks have sprung up that are much simpler, that take a lot of the market share from the the large application layers. It's interesting to see that resonate, right? That simple is better. It's interesting to see how Java as an industry is moving and trying to adapt.
You talked about threading, and that threading or concurrency could make an application a lot more complex. I would agree to that completely. But do you think that threading can be useful to improve performance? If I think about the UI thread and having a responsive UI, that you defer stuff to a background thread instead doing it in the UI thread, for example?
Oh yeah, no, it's absolutely essential. There are many horror stories of clicking something in the UI and going off to a database and spending 10 or 20 seconds because your network connection is down before the UI is released and the end user can use it. Those sorts of things happen a lot, and they're unfortunately extremely easy to do. It's a constant effort to not have long-running operations block the UI thread, and so I would say it's essential that you understand and use what your platform provides to you. I mean, with that said, I'll again use the example of Eclipse. Eclipse has a jobs framework, which is basically threading. It's a thin layer that uses threads under the covers and uses a pool of threads. And so if you're writing Eclipse-based applications or rich client applications on Eclipse, then that's what you should definitely use. But I've also seen people go too far. So a good example is if you imagined a mail client and you open your inbox, and let's say you want to do some long-running operation for each of the users. You may want to get whether they're online or not, their status. I've seen people before create a job to do that, which is the right thing to do, but unfortunately they created a job for every person in the inbox, which isn't the right thing to do because you'll basically blow your thread pool and you'll create a thread then for every single person in your inbox, which is a bad idea if you have many emails. So you definitely have to be aware of what your underlying framework is providing to you and use it appropriately.
But you would say such a thin layer like the Eclipse Jobs API or similar stuff is useful instead of programming the threads and monitors by hand?
Yes, absolutely. I mean, even before Eclipse did their jobs framework, I was a big fan of Doug Lea's concurrency utils.
Oh yeah, very good example.
Yeah, which I guess go all the way back to 1.4 is I think where they were first introduced. So yeah, I'm a big fan of his work and try to get people to use that instead of using the primitive monitor synchronization that Java provides out of the box. But sometimes you have to.
Yeah, but I observed in projects that you sometimes it's just the pure hell to say put long-running operations in the background using these low-level operations and having the swing thread, and you cannot change the model of
Yeah.
whatever without getting really strange behavior at the UI
Yes.
because you change the model in a different thread and stuff like that. So
Yep.
sounds like some API and some very maybe thin layer above that is very useful.
Yes. Yeah, I would agree.
So we are now close to the end of the episode. So I would like to ask you the typical question at the end. Any additional pearls of wisdom you would like to share with our listeners?
I guess it would really just be a recap. In my opinion, the key to performance is having clearly defined goals, good automation and good scripts that you can use to drive load, and and then basically as you execute those goals, you're collecting the performance metrics of each of the machines, and it's important to then store that information historically. And then with that information, you then have a good basis for how to make improvements and what areas need improving. And once you have that, then you pull out your profilers, then you pull out your network analyzer tools, and you dig into fixing those problems. But until you can measure it, it's difficult to improve it. Or if you do improve it, you don't have much guarantee that the next build it won't regress and you won't notice because you aren't measuring it.
Oh yeah, good summary of the episode. I think we could dive into much more detail about how to exactly analyze those problems, but that might be a topic for another episode. So I would like to thank you very, very much for taking the time talking with us about performance engineering, and thank you very much.
You're welcome. I'm a big fan of the show.
Thanks.
Thanks for downloading and listening to Software Engineering Radio. Software Engineering Radio is an educational program brought to you by Hillside Europe. If you want more information about the podcast and all the other episodes, visit our website at se-radio.net. If you want to support us, you can donate to the SE Radio team via the website, or you can advertise for SE Radio, for example by clicking on the Dig, Reddit, Delicious and Slashdot buttons. To contact the team, please send email to team@se-radio.net, or if it is specific to an episode, please use the comments facility on the website so other people can react to your comments. This episode of SE Radio, as well as all other episodes, are licensed under a Creative Commons 2.5 license. Please see the website for details. Thanks to Charlie Crow and the Podsafe Music Network for the music used in this show. The song is called Vegas Hard Rock Shuffle.